Hey friends, my name is C and you're watching Makes It Easy, and welcome to a new video for IGCSE at Maths. And today we have questions for circular measure, and these questions are from DrFrostMaths or DFM. So if you want the PDF, you can check out in my website or you can check out the description. And before you get into it, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And now we have question 1. Calculate the area of this sector, giving you an answer in 3 significant figures. So remember, area is equal to half r squared theta, and we have to keep in mind that this theta has to be in radians. So it'll be half 45 squared, and for 84 degree, from degree to radians, we have to times by pi over 180. So it'll be 84 over 180 pi, and if you put that into your calculator to find a final value, the final value will be around 1480 to 3 significant figures, and that's the answer. And number 2, calculate the length of arc ABC of the sector, so this right here. So I'll give you answers in 3 significant figures. So we know that the arc length formula is S equals r theta, where theta has to also be in radians. The radius is 10.4 centimeter times the theta, which is 120, divided by 180 times by pi to get a radians value. And if you put that into a calculator, you get an answer of 21.8 centimeter, and that's the answer. So 21.8. And number 3, find the perimeter of the shaded region. Give your answers to 3 significant figures. So we have 4 right here, this, and this must be 4 as well. So we have to find this and this. And you can notice how they're both arc length with the same value of the theta, which is the angle. So we'll do the perimeter. Perimeter equals 4 plus 4 plus, let's find this S1. Because the arc length 1, the smaller one, will be S equals r theta, r times theta, which is 75 over 180 pi, plus by the bigger arc length, which is 6 plus 4 for the radius, 6 plus 4 times 75 over 180 pi. And if you add everything up and times everything up and add everything out, you get a final value of 28.9 centimeter, and that's the answer. Number 4, OAB is a sector of a circle, center this. Work out the length of AB, giving you answers in terms of pi. This right here. So it will be S equals r theta, r is 12, times the theta, which is 60, divided by 180 pi. So this will equal to 12 times 1 over 3 pi, and 12 times 1 over 3 will be 4, therefore it will be 4 pi. Right, so, and that's the answer. So the length of AB, arc AB, is 4 pi. Right, so then we have question 5. The area of a sector is 112 pi cm squared. Find the value of x. So this is a huge segment, and we can just use the area of a segment formula. So the area of a segment will be A equals half r squared theta. It will be equal to 112 pi. So it will be, let's just put it up here. It will be r squared theta equals 112 pi times by 2, which is 224 pi. 224 pi. R squared will be 12 squared pi equals 224 pi. Therefore, the pi value, which is the angle or the x, will be 224 pi divided by 12 squared, which is 144, and that will get you an answer of 280 degree after converting it to degree. Because without turning it into degree, the radians that you get 14 over 9 pi, which is the same as 280 degree. And question 6, The diagram shows the sector of a circle radius n. The sector has a perimeter of 25 cm and work out the value of x. So we define this, which is s equals r theta. So the perimeter will be 9 plus 9 plus 9x, because x is theta. This will equal to 25. And if you rearrange it, you get 9x equals 7, and therefore x equals 7 over 9 radians. But we're not done yet because we have to turn it into degree. To turn radians into degree, you do the radians times radian times 180 over pi. So you get a final value of around 44.6 to 1 decimal place. And that's the answer, 44.6. And question 7, we have this angle BOC equals 38, so on. Work out the area of OABC, the whole thing. Work out the area of the whole thing, giving answers to 3 significant figures. So what we can do is that we can find this length right here, which will use the cosine rule. Let me just put it up here. X squared equals 12 squared plus 16 squared minus 2BC, which is 2, 12, 16, cos 60. And this will get you an answer of x equals 208, which means, x squared equals 208, and therefore x equals 4 root 13. So now we have this area right here, this x 4 root 13. We can basically just find the area. We can split this into half, like so, and find this area using half AB sine C, and use this using the sector area. So area of the triangle on the left will be half AB 12 times 16 times by sine C, which is, we'll use it in radians, so it'll be 60 divided by 180 pi in radians, plus, I'll just write it down here, plus the area on the bottom of the sector, like a slice from a circle, will be half r squared, will be 4 13 theta, which is 38, but we'll turn it into radians, like so, and like so. And that will give us a final value of, like if we add everything up and times everything up and square it, it will get us a final value of 152 centimeters square. And that's the answer. And question 8, calculate the area of the sector, give your answers to 3 significant figures. So what we can do is that we can just find the radius first, So we know that arc length equals r theta. This will mean 7.2 cm equals radius times 75 over 180 pi. And therefore, the radius will be, let me just put into my calculator, like so, 7.2 divided by 75 over 180 pi. And this will get us a radius of, let me see, 5.50 centimeter. So now we have the theta and we have the radius. We can just find the area. Area equals half r squared theta, which means it's half 5.5 squared times 75 over 180 pi. And this will get us an answer of, let me just put into my calculator, half times radius squared times 75 over pi, 75 over 180 pi, to get an answer of 19.8. And that's the final answer. And question 9, the diagram shows a sector and calculate the shaded area. So remember, we have a formula for it. For this shaded area, it will be half r squared theta minus sine theta. It's like a shortcut. So let's just do area equals half r squared theta minus sine theta equals half the radius is 5.4 squared. Theta will be 72 divided by 180 pi minus sine 72 pi over 180. And this will get us a value of, let me just put into my calculator to find a value of 4.46 cm squared, and that's the final answer. And question 10, work out what percentage of the area of the circle is shaded. So we have this right here, this small circle right here. So this small segment, remember the formula, half r squared theta minus sine theta, close bracket. The area will be half 30 squared. Theta is 80 over 180 pi minus sine 80 over 180 pi, which will get us a value of, let me just see, 185.16 is number 1. And to find the percentage, it will be the total area this small area divided by the total area times 100 to get the percent. So it'll be 185.16 by the total area of a circle, pi r squared, pi 30 squared times by 100, and this will get us percent. This will get us a final value of question number 10, 6.55, and that's the final answer. And question 11, we have calculated the area of the shaded segment, giving you answers in 3 significant figures. So we know that this is an isosceles triangle because they're both radius, and this is 35 degrees. So to find this angle right here, and you have to use the total 180, like the whole pi, minus theta to get this one right here, which is what we want. So the angle that you want, like let's say alpha, equals pi, the whole 180 degree, minus 180 bracket, minus 35 degree, and this will get pi minus, and just put into my calculator, 180 minus 35 equals 110. But we have to convert this into radians first. 110 equals 180 pi. Put into a calculator, pi minus 110 over 180, pi 180 pi. This will get us a value of, let me see, 7 over 18 pi, number 1. So we have this, the angle right here, and we have the radius. That means we can find the area straight away of the shaded region. So area of the shaded region will be half r squared theta minus sine theta, which will be half 9 squared 7 over 18 pi minus sine 7 over 18 pi, to get a final answer of question number 11, to get a final value of 11.4 cm squared, and that's the final answer. And question 12, we have calculated the perimeter of the shaded segment, giving an answer in 3 significant figures. So from here we can see that the area of a sector is 5 pi cm. So the area is 5 pi, and we know that the area formula is half r squared theta. So it will be 5 pi equals half 36 theta. Because r is 6, 36 divided by 2 will be 18. Therefore, pi is 5 over 18. Sorry, theta is 5 over 18 pi. 1. So once we have the theta, the angle, we can find the arc length. And the chord right here, this is called a chord. And the chord formula is 2r sine theta over 2. So perimeter will be bracket 2 times 6 times sine pi, which is pi over 2. This thing plus the arc length, which is s equals r times theta. S equals r theta. Oops. X equals r times by theta, which is theta. Just use this value right here in the theta, and you get a final answer of 10.3 cm for the perimeter, and that's the answer. And question number 13, both watch faces have the same radius of 2 cm and materials and blah blah blah, and A is made of plastic and so on so on so on, and the ratio per cost for the metal to plastic is 3:2. So metal to plastic is 3:2. And to convert it into like normal like form, we just cross multiply it to get 2m equals 3p for the price. So we can find out this price, the area of the face A, it will be pi r squared, which is 4 pi. And it is made entirely out of plastic, so 4 pi times plastic, which is 4 pi p, basically 4 pi p. 4 pi p for A. And for B, it's basically 4 pi is the same area, but 20% is for metal. So 4 pi times 10% is 0.2. If you put into a calculator 4 times 0.2, you get 4 over 5 pi. It will be metal. So 4 over 5 pi metal plus by, let me just see, 4 pi times by 0.8, which is in plastic, which is 16 over 5 pi plastic. So we can actually simplify this to make everything to the same constant or variable. 4 pi p equals, the m can be replaced to 3 over 2p. So it'll be 4 over 5 times 3 over 2 times pi times p plus 16 over 5 pi p. So if you simplify everything, it will be 4 pi ratio 37.9p, and you cancel everything out to get 37 over 9, and times both sides by 9 to get 36 and 37, and that's the answer, 36 to 37, like so. So now we have question 14, the last question. So we have this neck of a cone, and the neck is a sector of a circle, center O, and so on. Find the vertical height of a cone. So this will be like a cone, like so, and you try to find this height right here. So what we have to do is we have to find the circumference of the whole circle first. It's basically pi equals 2r. The r is 15, so it'll be 30 pi for the perimeter. Now we have to find the circumference of the circle that will make up the base of the cone, which is 30 pi times 216 degree over 360 degree as a mean for the ratio. And we'll just put into our calculator 30 pi times 216 degree over 360 degree, which will get 18 pi, like so. So basically the circumference of the circle that will make up the base is 18 pi. So this cone right here, I'm assuming it's a whole cone, that will be 18 pi, like so. And now we have to work out the radius of this circle. Because we have the circumference is 2r pi equals the circumference, and we know the circumference is 18 pi. That means we can cancel. So we get 2r equals 18, and therefore r equals 9. So now we have the radius is equal to 9. So just split this like this, draw it like this. So this radius here is 9. And we know that the slant height is 15 from here. So it'll be 15. So now we have a Pythagoras which we are familiar with. So it will be a squared plus b squared equals c squared. And a squared is basically 9. 9 squared plus b squared equals 15 squared. So if you, let me just write this out here. So if you rearrange the equation to get b squared equals 15 squared minus 9 squared, and therefore b equals root of 15 squared minus 9 squared. And if you put into a calculator root 15 squared minus 9 squared, you get an answer of 12. And that's the final answer, 12 centimeter. 12 cm. And that's it. And that's it for this questions video for IGCSE at Maths. But today we look into circular measure, and I hope you'll find it useful and helpful. And if you did, please leave a like and subscribe, and ring the notification bell so that you don't miss out on any future videos. And if you have any comments or constructive feedback about my channel or my website or my YouTube, you can drop them off in the comment section and I'll reply to them. And also check out my social media in the description, for example LinkedIn or YouTube or Instagram. And if you need any learning resources or any teaching resources, you can check it out in my website in the description, or you can type it out in your browser at www.gmakesiteasy.com. And I hope you'll find it useful and helpful, and I'll see you all in the next video, which will be another rules and examples video. But until then, stay safe and happy learning.